Hey everyone, Junkyard Dog Bob here. Let me just get rid of this. Okay, sorry about that. Junkyard Dog Bob here, also known as Bobby to most of you because I don't really get this video out that much. I haven't made a video in a while of Agatha like I wanted to. I did do some work on her, but I just didn't get a chance to film it or anything, and it wasn't really all that impressive. It would have been really hard to try and show because it was mainly just just internal workings, nothing that you can actually externally see. Software, I mean. It was just changes in the way I did the software and everything. I did do one piece that was controller controlled with a 360 controller, and I had it to where if it got too close to a wall, it would shut down the driver's ability to drive, back up 5 centimeters, and then tell you that you could have command again via a GUI. So that was pretty impressive. But I didn't get a chance to film that. But I did want to make a video for this because I've been thinking about different ways to work on Agatha, and I haven't really done any work on her because I just didn't have a good frame. I didn't have the ports working. I couldn't find the time because of college. So I'm on spring break now. I wanted to do something with Agatha. I brought her home. Didn't know what to work on. Then I noticed that we had these those 12-pack of sodas, fridge packs of Pepsi, and I got to thinking about how cardboard can be used as a frame if you know what you're doing. And so I decided that the only plausible thing to do would be to create a Pepsi tank. So there you go. Here's the Pepsi tank. These add support because the treads are so close to the front, and sometimes they can't always carry the weight. This here is a little light switch that the human operator controls when it works. Well, there we go. See? So that's nifty. I'll try and make that button easily accessible. In front, you have right here that old distance sensor mounted into the cardboard so it doesn't fall all over the place now. And then on the inside, try and lift you guys up. You've got battery pack back here, the main Agatha board, and then this hard drive right here. It's just a corrupt hard drive. I just use it to create a counterweight. I have the Arduino board mounted directly to the cardboard, and underneath it, I'm kind of scared to lift this thing because its integrity is terrible. Underneath it is a gearbox, the same one I had in the old Agatha. So yeah. That's the design. The great thing about this is, if this works, I can hook up the gyro and the accelerometer, no problem, because I have plenty of room in here. I can add levels using pieces of cardboard. What I am going to do, though, is if this works, I'm probably going to build it a second time with another box, because my first design on the wheels didn't work so well, so I cut a lot of holes that weren't needed, and like the top, I'm not sure I really need to have that top cut off. I don't know. Or maybe like make it a flap or something so that you can fold it up and down so that it looks better. Find some way to keep integrity better, because right now it wants to fall apart badly. I'm not sure it'll last very long. That's why I haven't run it yet. Anyway, I'm going to stop it now. Go ahead and do some programming on it and stuff, but the first time I run it, you'll get to see whether it fails or whether it works. So, you'll see me in a couple seconds. I'll see you in probably an hour. Okay guys, so I thought about it. I decided that some of y'all may have seen an old ramping function I designed for Agatha that tested out the motors to see how long it took them to ramp up, and how they could all, at what power they needed in order to actually move, things like that, and it tested out all the functionality. I thought that would be a good idea since it was meant to be debug code anyway. I'd go ahead and run that first. I haven't ran it yet. I'm about to. You'll get to see me run it. And I think I messed up the wiring, so I have absolutely no clue what this thing is going to do. Here goes nothing. 3, 2, 1, fire. I stopped it because one of the treads is coming off. I'll fix the treading, and then we'll just go ahead and go straight back to it. I'm not going to bother trying to make a different video. Okay. Let's say you retry that again. 3, 2, 1. Wait. 3, 2, 1. Fire. Tread came off again. This time the other tread. I wonder why it keeps doing that. Ooh! That's a really bad way for that to happen. Wonderful. The whole wheel came off. Alright, if I can't get this thing fixed in another second or two, I won't bother you making you watch me fix it. Okay. No, don't do that. That's the opposite of what I want you to do. Come on. The thing is, I actually know why it's doing this. And it's because this is a prototype and I didn't cut the cardboard correctly. Okay, I'll have to cut that cardboard some more. I won't bore you with that. But that was amazing. I have one of the motors wrong, but the fact that it can actually carry that weight at that speed was really impressive. And that was turning. And turning should always be slower and harder to do. So the fact that I could turn that well, I'm really impressed. You have no idea. So I'm going to fix that, cut the cardboard. I'll, either in this video or in another one, I'll show you it working even better. It's going to be great. It is. Signing off.